Hello everyone, I'm Zhou Feng from Huawei Global Training Center, Data Communication Department. Today we'll talk about TCP IP basics. Before I introduce about TCP IP, let's see about the OSI. This is OSI reference model. This model designed by ISO organization, and it has 7 layers. From the bottom to top, we have physical layer, data link layer, network layer, transport, session, presentation, and application layer. This is what we have learned in school, in university. So it has actually 2 parts. This is low layers, in charge of data transmission in network, and high layers in charge of data transmission between hosts. That means this low layers is processed by network device, and high layers is processed by the terminal, such as the host, server, and your mobile phone, and so on. This is a comparison between OSI to TCP IP. The layer number is different. We can see the physical data link, network, and transport, they are same. But in TCP IP, application layer is same to these 3 layers. And actually, TCP IP is widely used, but OSI, it's hard to use a device or something to describe which one is working in presentation layer, which one is working in application layer. Maybe these 3 layers is by one host or one software. So the OSI is not widely used. The TCP IP is our current standard. This is TCP IP Protocol Stack. From the physical to application, we can notice interfaces, wires, Ethernet. Ethernet is very useful and popular. IP in network layer. We have IPv4 and IPv6. Transport layer, we have TCP or UDP. From the TCP IP name, we notice IP and TCP is 2 important protocol in this protocol stack. In application layer, multiple protocol is running in this layer, such as HTTP, Telnet, and FTP, and so on. This is data encapsulation. In host, there's a host. This host need to forwarding a packet or forwarding a data to another host. So how to process this data, this information? From the application layer, it generates the data and it will encapsulate in the transport layer. And we call the originate data. This data encapsulate in TCP header. For example, the transport, we have TCP or UDP. This time we use TCP encapsulate. And this header and this data, we call that is segment, consists of segment. Okay, after encapsulate, it will process in another layer, in the network layer. The TCP and data become to upper layer data, and we add an IP header before it. It will become to packet. In different layer, it has different name. Next layer, to LLC header and the upper layer data. And then with MAC header and FCS trailer, we call that is a frame. Frame is working on layer 2. And then we transmit it into binary mode, 010101, and forwarding it to physical layer. It's bit flow. The reverse way will working on another side. The host B, when it receiving this packet, will process from the physical to data link and to network and to transport, then back to the originate data and processed by the software. Physical layer, median, and device. Today we have only one or two devices working on physical layer. Maybe the repeaters and hub, because hub, the forwarding speed is very slow, so it's not usually to use hub. We use the switch and other devices on high layers. The function of data link layer. Data link layer has two sublayers. It's MAC sublayer and LLC sublayer. Here, MAC sublayer and LLC sublayer. MAC including about the MAC address of the source and destination, and LLC it control the encapsulation by higher layer. How to de-encapsulate? It need to writing this information, the high layer information, in this LLC sublayer. Okay, let's see about the MAC address. MAC address, if we want to forwarding the traffic on Ethernet network, we need to know each other's MAC address. MAC address consists of two parts, the vendor code and the serial number. Totally 48 bits long. The vendor code in different vendor, this code is different, and the serial number is by the product produced series. In all this NIC card or network devices, the interface, all of them, this MAC address is unique. So even they are in the same local area network, there's no conflict. The function and the device of network layer. The function is data forwarding in different network device. The typical device in this layer is router, and all layer 3 switch. They have the similar function. Okay, here is one topology. One host from router A forwarding a packet to router A, and router A has multiple paths to destination host B. The router will select the best route forwarding the packet from one by one. Each hop they will looking in its routing table and de-encapsulate and encapsulate. If this packet destination is not itself, it will continue looking for the IP routing table and then forwarding to next one, until this packet forwarding to destination host B. Okay, this on host B, it will de-encapsulate all this packet header and to originate data by process. Network address. This is we can also call IP address because we use IP protocol. It can consist by network ID and host ID. For example, we have 10.8.2.48. This address, the network ID can be 10. The host ID can be the left part. The function of transport layer. The transport layer is near the application, so it need to segment upper layer data. Because the data is very big, we need to cut it into the segment. Set up end-to-end connection, transmit data from end to end, ensure the reliable data transmission. Actually, there are two protocols. TCP and UDP. Compared with these two protocols, the TCP connection-oriented and UDP is connection-less. The reason is why we said it's connection-oriented, because TCP is transmit data by session. For example, when it established, it need to both of sides negotiate, and then for each data packet into acknowledge, so that is session. If it realized by session, it is connection oriented. And then reliable and trustless, because TCP in TCP session, if the packet has lost or not received, it has the retransmission mechanism. Okay, then application with high reliability suit high reliability, because if there's packet loss, some data will be lost. Application cannot process. So if your application need reliable transmission, choose TCP. And finally, high cost. High cost means if each packet, each segment information need to acknowledge, the cost is a bit high. Okay, the UDP suitable for application that concern transmission efficiency. So that means UDP forwarding very quickly. It's suitable for such as voice and video type of service. Reliable depends on application. The UDP cannot providing any reliable. If this packet loss on both sides, they note there's no retransmission. Okay, finally we go to the function of application layer. This layer provide user interface and deal with specified applications. Actually, in this layer is processed by the software. Okay, in this chapter we have learned TCP IP Protocol Stack. We have 5 layers. Data encapsulation, one by one, from the application to transmission, and one by one encapsulation. And the reverse is called de-encapsulation. In this chapter, we have this question. What's the transport layer encapsulation name? You know, in each layer, the encapsulation is different. In transmission layer, the name is segment. That's all for this chapter. Thanks for watching.